in this one too. Hey, it's Mr. K. This is the homework for Geometry, Unit 10, Lesson 10, the volume of spheres. So hopefully it's a help, and hopefully everyone's doing all right. Alright, so this is Geometry, Unit 10, Lesson 10 on spheres. So the formula we have is volume equals 4/3 pi r to the third. So the number one, a basketball has a diameter of 9.4 inches. Which of the following be close to the volume of the basketball? So they love doing this. When I say they, I mean the regents, giving you the diameter and not the radius. So if the diameter is 9.4, the radius is half of that, which would be 4.7. So that's the only measurement we need of a sphere to calculate the volume. 4/3 pi times 4.7 cubed. And then from there we type it into our calculator. I like to use fractions, but you don't have to. You can just 4 divided by 3. 4/3 times pi. If you don't know, the pi button's right here. Oh, you can't see that. Can you? Right here above this, I call it the caret. That's what we use for exponents. So pi is right there. You'd have to hit the second button and then that to get pi. So 4/3 pi times 4.7 to the third. So I actually had to use that caret button to get to the third. Okay. So now, enter, we get 434.89. So the best one is 435 cubic inches. Alright, number two, largest sphere that can fit inside of a cube whose volume is 1,000 cubic inches. So a cube has all sides the same. So I'm drawing a cube. For a cube to have a volume of 1,000 cubic inches, then each side would have to be 10, because 10 times 10 times 10 is 1,000. So if we were to draw, and this is kind of tough for me, I'm not the best at this, but a sphere inside of that, then what we'd have to picture is that this sphere would have a diameter of 10. It would go all the way across that cube. So the diameter is 10, but again, we need the radius to calculate volume of the sphere. So the radius would be half of that. So volume equals 4/3 pi times 5 to the third. Now if you notice, their choices are in terms of pi. So what we could do, let's do the 4/3 times. So 4/3 times, we'll do the 5 to the third. And we get 500 over 3. And that would be 500 over 3 pi. And that was closest to choice number one. Another way to do that is to get the decimal value and then type these in to see which one equals approximately that decimal value. Kind of like what we do with square roots. Where if they leave it in simplest radical form, we kind of just go through the choices and see which one best fits. Alright, the next one, a hollow metallic ball is created that has an outer diameter of 10 centimeters and a thickness of 1 centimeter in all directions. Which of the following expressions could be used to calculate the volume of the metal used in units of cubic centimeters? So this outer one has a diameter of 10. So let's call this one the outer one. So the radius of that one will be 5. The inner one, let's see here. So if this is 5, it says that it's a centimeter in every direction. So that's 1 centimeter there. So the radius would be 4. So the inside one would have a radius of 4. So volume equals, we're going to do the outside one first, 4/3 pi times 5 to the third. Alright. The inner one would have 4/3 pi, now its radius is 4 to the third. So if we want to do what's left, or remaining, we would take 4/3 pi times 5 to the third minus the inner one, 4/3 pi times 4 to the third. Now the reason why I'm doing it that way is you can kind of see our choices aren't exactly just a number answer. So notice that with the work that I wrote down, both of these terms have a 4/3 pi. So what I can do is actually factor that out. And then in parentheses put what's remaining, which is 5 to the third minus 4 to the third. Here minus this. And if we take a look, that's actually choice number 4. Again, what could you do if you didn't want to factor out? You could find the decimal value of all of this and then go through each choice, okay, on your calculator and figure out which two match up the best. I just chose to do it that way because I noticed these choices were kind of factored out, so that's where where my brain headed. Alright, a spherical baseball has a radius of 1.47 inches. So they do give us the radius in this one. And weighs 11 grams per cubic inch. Which of the following is the closest to the weight of the entire baseball? So in order to do this, if it's 11 grams per cubic inch, we need to know how many cubic inches is that baseball. So volume equals, that's volume, times pi times 1.47 cubed. So volume equals, so I'm going to type that into my calculator. I just brought up that, so 1.47 cubed. We get about 13.3057 blah blah blah. Now instead of writing that down, well, I'm guessing I'm going to write some of it down. I'll do about 13.31. Now this is where we're going to use this, it's actually a density. 11 grams per cubic inch. So what that tells us, it's 11 grams for cubic inch. So we can actually make this into a proportion. 11 grams in 1 cubic inch. So how many grams in 13.31 cubic inches? That's our answer here. So if we cross multiply, we get x times 1 is x. So that's the number of grams. We just have to do our answer here times 11. 146.4. Well, how about just 146 choice 3? Okay, so on to the back. Alright, so we've got a punch bowl in the shape of a hemisphere. The top rim has a circumference of 116 centimeters. My first question would be, how can it sit on its bottom? If it's a hemisphere, it's just going to roll all over the place, but I guess that's not the point. Anyway, volume of the punch bowl to the nearest cubic centimeter. So the tops, it tells us, has a circumference of 116. So, in order to calculate volume, we need the radius. In order to get the radius, we need to convert circumference back to, I'm going to actually convert it back to diameter, because I know that circumference is pi times diameter. So if I divide this by pi, I'm going to get the diameter. So 116 divided by pi, I get something about 37. But again, we need the radius, so 37 divided by 2 is 18.5. So about 18.5 centimeters is the radius of that punch bowl. Alright, so the volume would be 4/3 pi r to the third. So that's 4/3 pi times 18.5 cubed. So 4/3. Now you could also just type in 4 divided by 3 times, I just like using a fraction, times, we get 18.5 cubed. Now the thing is, that's for the entire sphere. This is half of that. So we'd have to divide that by 2. So this punch bowl has of volume. Now it says to the nearest cubic centimeter, so the volume would be roughly 13,261 cubic centimeters. Alright, next, if there are 1,000 cubic centimeters in a liter and 3.785 liters in a gallon, determine to the nearest tenth of a gallon how much punch can fit in the bowl. So this is actually going to be two proportions. We're going to have a proportion to deal with this part that I'm underlining in green. We're going to need a proportion for this part that I'm underlining in purple. So we're going to actually we're going to take our pink answer here to change it into liters. We're going to take our green answer here that will now be in liters and put it into this one, which I have in purple, to change it into gallons. So we got line equal sign line, 1,000 cubic centimeters in 1 liter. Alright, so then we got 13,261 cubic centimeters is how many liters? So if we cross multiply, we get 1,000 times O equals 13,261. So we'd have to divide by 1,000. Now I'm able to do that quickly. You could do it on your calculator, but it does turn out to be 13.261 liters of punch in that bowl. But that certainly isn't good enough. We need to change that to gallons. Line equal sign line. 3.785 liters in 1 gallon. So 13.261 liters is how many gallons? Cross multiply. 3.785 times X equals 13.261 liters. We don't need that right now. We're going to divide by 3.785. So 13.261 divided by 3.785. So 3.5, it says round to the nearest tenth of a gallon. 3.5 gallons. I wrote in cursive. I haven't done that in years. Okay, next one. A pill has the shape of a cylinder with a hemisphere at each end. The height of the cylindrical portion is 12 millimeters and the overall height is 18 millimeters. Find the volume of the pill in cubic millimeters, round to the nearest cubic millimeter. So let's do, how about we take care of, well actually, you know what we need is the radius of this first, because we need that radius in order to do the cylinder and the sphere. So a little problem solving. If this is 12 and this is 18, then that means there's a 6 millimeter difference between the overall height and the height of the cylinder, or the cylindrical portion. Now, I'm going to assume that those two are the same, okay, what I just drew here and here, which would also be the radius of that sphere, which would also be the radius of that circle. So if it's a 6 millimeter difference between the two, then that means that I would imagine that this is 3 millimeters and this is 3 millimeters, making the radius of that circle 3 millimeters. Alright, so what we're going to do is we're going to do the volume of the sphere, and then we're going to do the volume of the cylinder. Alright, so the sphere, 4/3 pi times 3 to the third. So 4/3. Oops. Pi times 3 to the third. 113, let's say 0.1. Alright, now the volume of the cylinder, or the cylindrical portion, would be, so if you haven't watched the cylinder video on eMath or the homework, you might want to go do that, because cylinder, the volume is basically the area of the circle times the height of the cylinder. So it's pi r squared, that's the area of a circle, times its height. Cylinder has a height of 12. So we're going to do pi times 3 squared, that's the radius, times the height, which is 12. So pi times 3 squared times 12. 339.3. So, altogether, it would be the sphere, 113.1, plus the cylinder, so about 452.4. And that's in cubic millimeters. Alright, if the pill is to contain 1,000 milligrams of vitamin C, then how much vitamin C does the pill contain per cubic millimeter? Round to the nearest tenth of a cubic millimeter. To contain 1,000 milligrams of vitamin C, how much vitamin C does the pill contain per cubic millimeter? Alright, so 1,000 milligrams. And we want to figure out, so per cubic millimeter. So right now that's 1,000 milligrams in 452.4 cubic millimeters. We want to figure out how many milligrams in 1 cubic millimeter. So we could cross multiply. I'm actually just going to divide by 452.4. Right, so 1,000 divided by 452.4, we get about 2 point, now it says round to the nearest tenth of a cubic millimeter, so 2.2 milligrams per cubic millimeter. Alright, last one. Another pill that is entirely spherical has a diameter of 10 millimeters and contains 1.5 milligrams of vitamin C per cubic millimeter. How much less vitamin C does this second pill contain, rounded to the nearest milligram, than the one pictured? So first let's get, now it says diameter of 10, so the radius is 5 millimeters. So the volume of this spherical pill is 4/3 pi, and we said what, 5 to the third. 523.6. That's cubic millimeters. Contains 1.5 milligrams of vitamin C per cubic millimeter. How much less vitamin? So what we have to do now is, this is telling us that this pill, this spherical pill, has 1.5 milligrams of vitamin C per cubic millimeter. So how many milligrams does it have if, now that we know it has 523.6 cubic millimeters in it? So again, I'm going to just multiply times 523.6. So 1.5 times 523.6, 785.4, and that's milligrams of vitamin C. But still, how much less does this one have than the first one? First one is supposed to contain 1,000 milligrams of vitamin C. This only has 785.4. So 1,000 minus 785.4. So how much more does it have, or how much less does that one have? That one has 214.6 milligrams less. A lot to that one. All right, hope everyone's doing well. Hopefully these are a help. Send me a message, let me know, email, let me know if you need anything else. All right, take care.